students, welcome to chemistry lab. Now we are going to analyze the seventh salt. The given simple salt contain an anion and cation. Identify and confirm the presence of anion and cation. First we have to identify the anion present in the salt. First test is test with dilute hydrochloric acid. This is the seventh salt we have to analyze. The salt contains an anion and cation. The given salt is taken in a test tube. To this add dilute HCl. No brisk effervescence is formed. This shows the absence of carbonate as anion in the given salt. Next is test for acetate. Reagent used is dilute sulfuric acid. For this, a little of the salt is taken in a watch glass. To this, about 1 ml dilute sulfuric acid is added. Rubbed well with our fingers and the smell is noted. No vinegar smell is observed. Shows the absence of acetate. Next is test for chloride. Reagent used is concentrated sulfuric acid. A little of the salt is taken in a test tube. To this added concentrated sulfuric acid. It is gently heated. No evolution of white fumes shows the absence of chloride. Next is test for nitrate. The reagents used are concentrated sulfuric acid and paper board. A little of the salt is taken in a test tube. To this add concentrated sulfuric acid. Gently heated. A paper bowl is added. Again heated. Strongly heated. Brown fumes shows the presence of nitrate. Thus, we identify the presence of nitrate in the given salt. Now, we confirm the presence of nitrate by performing brown ring test. The reagent used for the test are ferrous sulfate solution and concentrated sulfuric acid. For performing brown ring test, freshly prepared ferrous sulfate solution is needed. For brown ring test, we have to prepare salt solution. Mix equal volumes of salt solution and freshly prepared ferrous sulfate solution. To this solution, add concentrated sulfuric acid carefully along the sides of the test tube without shaking. Brown ring is formed at the junction of the two solutions, confirms the presence of nitrate in the given salt. Thus, given salt contains nitrate as anion. Thus, we identify and confirm the presence of nitrate as anion in the given simple salt. Next is test for cation. For cation analysis, we have to prepare salt solution. The first test is test with the sodium carbonate. The salt solution is prepared by mixing the salt with the water in a test tube. To the solution taken in a test tube, sodium carbonate solution is added. Formation of white precipitate shows the absence of group 0, that is ammonium, in the given salt. Next is test for group 1. Group reagent is dilute HCl. About 2 ml of the solution is taken in a test tube. To this add dilute hydrochloric acid. Formation of crystalline white precipitate shows the presence of group 1 cation lead. Thus, we identify the presence of lead as cation in the given simple salt. Now, we confirm the presence of lead by performing confirmatory test. The tests used are potassium chromate test and potassium iodide test. First test is test with potassium iodide. A little of the salt solution is taken in a test tube. About 1 ml potassium iodide is added. Formation of yellow precipitate confirms the presence of lead. The yellow precipitate formed is dissolved in hot water and keep aside for some time for cooling. After cooling, we can observe golden spangles are formed in the test tube. This confirms the presence of lead as cation in the given salt. Next is test with the potassium chromate. To a little of the salt solution, potassium chromate solution is added. Formation of yellow precipitate shows the presence of lead. Thus, we identify and confirm the presence of lead as cation in the given simple salt. So, the given salt is lead nitrate.